All right, we're back. We're still on page 11, I think, of notes 15. And we are taking limits of Riemann sums and we are turning them into definite integrals so we could use the fundamental theorem on them. So that's like our objective. And then we have found the integral representation is not unique. You can get multiple integrals that give the exact same value because a definite integral is just a number. And they're all going to vary by basically u substitution. Like you can use a u substitution to change each one into the other. So let's see if we can do this one. We're always looking for like base times height. We're looking for dx. So I'm going to say this is the base. And if this is the base, then this is the height in some capacity. I think there's at least two things that we can do here. So if we say that delta x is 4 over n, I think a good choice is to say that x sub I is, oh look, we're using k instead of I in this case. So I guess, should I say x sub k? I guess I should. I bet I messed that up a million times. X sub k is going to be 3 plus 4k over n. And then if that's the case, what's f of x? Well, you're just doing x sub k, so it must just be x. So here, x0 is 3, xk, no, xn, dang it. Xn is 3 plus 4, so 7. So this, I think, is the integral from 3 to 7 of x dx, which you could 100% do by hand, right? So that's going to be 1/2 x squared. We don't care about plus c because it would just cancel itself out. So we get 1/2, and then 7 squared is 49, minus 1/2, 3 squared is 9, 1/2 of 40 is 20. So fundamental theorem is amazing. And it let us evaluate this limit. I have no idea how to do this limit other than to turn it into a definite integral. What if you look at this thing and you say, I think this looks a little different. I think that delta x is 4 over n, and I think that x sub k is actually 4k over n. So then x0 is 0, and xn is 4. And what's f of x? Well, you're doing 3 plus x sub I, so it must be 3 plus x. So now you have the integral from 0 to 4 of, I'm going to write it as x plus 3 dx. There's multiple ways to do this. And I've had, like, for whatever reason, I don't know what it means. My best students seem to do this one way, and then everyone else, including me, seems to do it a different way. So what I do is I will do 1/2 x squared plus 3x from 0 to 4, right? And plugging in 0 is the greatest thing in the world because it's just going to zero out. So I get 4 squared is 16 over 2 is 8. And then plus 3 times 4 is 12, minus 0 plus 0. So we get 20. That's how I do this problem. What I've noticed my best students do, and it's kind of weird, they do like a weird u substitution. It's not weird, actually. It like makes perfect sense. So I'm just going to do it. They do this. So they say an antiderivative of the quantity x plus 3 is 1/2 the quantity x plus 3 squared, which makes sense. Oh, I got to sneeze really bad. Do I? I do. I thought I did. Doing it this way is like really nice. I think it like makes, I don't really know. I mean, I think it's a little easier. 7 squared minus 1/2, 3 squared. I mean, no matter how you do it, you're getting 20. I think it's weird that like some people look at this problem and do it one way and others look at it another. Why does it work? It works because this and this, they're not the same, right? This has an extra constant term to it, but that constant term plus c, it's just a plus c. So they only differ by a constant. So the fundamental theorem is going to work for them. They have the same displacement on the interval from 0 to 4. It's kind of an amazing thing. It takes practice getting your brain around that, by the way. So like if you're like, what? Yeah, that makes sense. Like eventually you won't feel that way. Delta x is pi over n, x sub j this time. Great. X sub j, I'm going to say is, I guess like pi over 2 plus pi j over n which means x0 is pi over 2, and xn is pi over 2 plus pi, which is 3 pi over 2. So this is pi over 2 to 3 pi over 2 of just sine of x, right? Because I made all of the thing that's on the inside x sub j. So that's why that worked the way it did. All of this I made x sub j. So you're just doing sine of x sub j, so sine of x is your function. But a rational people can disagree on that and can think instead, delta x is definitely pi over n, but x sub j for some people is just going to be pi times j over n. And then you didn't make it all of that, you just made it this. So you're doing sine of pi over 2 plus x sub j, so x plus, nope, I got this. Do I have this? I hope so. Pi over 2 plus x is f of x. So we could do, oh, forgot it, x0, 0, xn is pi. Just go from 0 to pi of sine of pi over 2 plus x dx. We can check on a calculator, but you can kind of see that they're going to be equivalent. I mean, this, if u is equal to this, then when x is 0, you get pi over 2. When x is pi, you get 3 pi over 2, and it's like sine of u. Ooh, somebody forgot a dx. Who's that? Let's make that fix. Dx. Here we go. Woo, saved it. All right. Let's do one last, and then we're done with this page. And that feels pretty good. Delta x. This again, there's going to be two choices. I'm just going to do one. I'm going to say x sub I is, I'll do like the weirder one, I guess. I think that it's weirder to say that x sub I is this. Rather, I think the normal thing is 3 plus 4i over n. But I'm not doing the normal thing. I'm saying that this is it. So like, what's my function? It's 1 over 3 plus x sub I, so 3 plus x and squared. Why did I use 3 plus like all the time? Very strange. So then x0 is 0, xn is 4, so this should be the integral from 0 to 4 of 1 over, let's make it x plus 3 squared dx. So we can do that by hand. The easiest way to do it is to rewrite it as x plus 3 to the negative second. And then just think antiderivatives. Don't think like definite integrals. Always you're just thinking, how would I find an antiderivative? Well, like if this was u, then there'd just be a 1 here. So that's good. So I'm going to do plus 1 times the reciprocal. So that'll give me negative this thing to the negative first, but I'm going to write it as negative 1 over x plus 3. And then we're going from 0 to 4. So you will get good at these, I promise. First thing we do is plug in negative 4, you get negative 1/7, minus, plug in 0, you get negative 1/3. I recommend you always put minus parentheses, and then go from there with like whatever you're gonna end up with. So what on earth is this? This is 1/3 minus 1/7. So 7 minus 3 is 4 over 21. I think that's right. I don't know. All right, so should we check these, I guess, on a calculator? I don't remember which ones we did here. I mean, E is definitely right. F is definitely, they're all right. Let's check G. It's the only one that I like got a numerical value for, so like could be questionable. I want to do the integral of 1 over quantity x plus 3 squared. X is a variable, 0 to 4. Just use the template. It's like the easiest thing. So like, what would the equivalent integral have been? I think it would have been just, so I'm going to let u equal x plus 3, right? So if u is x plus 3, then when x is 0, u is going to be, when x is 0, u is x plus 3. So 3 and then 7. And then this I changed into u and then du. So this should also give me 4 over 21. And it does. So that is another thing. Like, the calculator is great for helping you practice that kind of thing. I think you should try to practice that kind of thing. But, you know, it's up to you, depending on how much time you have on your hands and how good you want to get at these things. I think your objective should be to get as amazing as possible, but I know you got other things in your life, but this would be worth it amongst the things you have to do in your life. Anyway, I'm going to end this here. These are all really good practice problems. You might want to try them over again, and I will see you in the next video.